Hi everyone, my name is Anna Zharkova. Welcome to Android Worldwide July. I'm ready to be the host speaker, and I'm glad to be the first speaker. So let me introduce myself briefly. I'm a mobile developer since 2013. I'm both native mobile developer and cross-platform mobile developer. Also, I'm a public speaker in different conferences and tutor in iOS courses, and author of different articles about Swift UI and Kotlin Multiplatform. Today's topic is how to make your existing Android application cross-platform. And we will discuss not only about Kotlin Multiplatform and its modern conception, but also how to add a shared model, set up it with common logic, make your native logic common and shared, and set up common architecture, and also make it working with iOS Target and Swift UI. So it could be interesting for those who are interested to dive into Kotlin Multiplatform, and for those who are already common with SDK and would like to know how to use modern and convenient solutions to make your existing native application work as cross-platform. So let's begin. Kotlin Multiplatform is an SDK by Jetpack's company that could help you to make the part of your code common. You could put everything you would like to share between different targets in a separated module, and then it will be compiled by different virtual machines specified for your targets in compatible library formats. For example, it will be framework for iOS and Java for Android. Currently, this SDK in beta state, but it is a stable beta, and the main specific of this SDK that since alpha state, it is used by many developers and companies that are fond of multi-platform and cross-platform development. So, and stable means that there could be several small differences between different targets depending on Kotlin version, and also by different implementations in, for example, not Kotlin JVM but Kotlin native. So this year, this SDK will be in final release, and I hope that it will be in final release, and then it will be the world of Kotlin Multiplatform. So it is SDK, not framework. Why? There is no default solution to work with UI. Of course, you could use approach of Kotlin of composed multiplatform for iOS and Android and work with Kotlin multiplatform, but it is separated solution and it is not Kotlin multiplatform by default, but just a tool that could be used together. There is no default approach for UI. You should provide your UI in your native applications, and also the same thing with platform dependency code, such as work with sensors and maybe maps. So it uses different virtual machine to compile with Android and iOS. Also, the common model, the shared model, is not solid. It could be separated in different parts, and there is a common part and part for every target. And in these different packages, different parts used different versions of Kotlin. For example, Kotlin Common works with every target. And for platform dependency code is Kotlin JVM that works with Android and Java, Kotlin Native that could be used with iOS and desktops, and Kotlin JS for web solutions. And you could provide in shared model most of your logic, most of your business logic. It could be network services and clients, database layers, data models. Kotlin and Swift are resembled by their syntaxes, and to provide the work of Kotlin and Swift code together, there is a mechanism of interop that make your Kotlin native code converted into Objective-C and Swift solution. Also, you could provide common architecture in common model. For example, you could provide common view model, not view model Jetpack Compose, but view model as an implementation of architecture pattern. Presenter, interacting, and everything you would like to use in your architect solution. To make several logic work differently in different targets, or in cases when there is different solutions that should be provided for different targets, there is a special mechanism of expect actual. You could define everything you would like to implement differently as expect and implement it in these target models and mark it as actual implementation, and then during the compilation the correct implementation will be mapped with default declaration. Let's begin with our practical case. We have small Android application that works with the Last.fm API, and let's make it multi-platform. So we have business logic and Android native logic. For Android native logic is view model and fragment. In my sample, there is not Jetpack compose, but you could also provide Jetpack compose instead of fragment, and there will be no sense at all for our case. So all the business logic could be provided in common model. Let's see what we use to work with business logic and UI in our native application. So there is retrofit for network, coroutines for concurrency, dagger or hilt for dependency injection, and view model Jetpack for our view model. And for navigation, I use Chicharone and JSON to provide deserialization. If we use our common logic for both iOS and Android, we need to provide solutions only for iOS native application. So iOS native application will be contained different view models and views. So it will be SwiftUI solution, and for this solution we need to provide libraries for images. So in my case it's Kingfisher, and for navigation I use SwiftUI Navigator, my own solution, but it could be also used native navigations. And of course mainly we use SwiftUI solutions to provide the most of our logic. Even the dependency between and the connection between our view model and the view model is made with SwiftUI library stack. So what will be used as common code? In our case, it will be data models. So there is our common data, and it will be a Kotlin code, also network client, API service, and architecture solution common view model. So it will be also Kotlin code. Currently, it is already Kotlin code, but with several differences. And what will be used differently? We will have different implementation for our navigation and different implementation for our UI, fragment and SwiftUI. Let's make our application cross-platform, and let's begin from adding shared model. So when we have existing Android application, turning it into cross-platform application, it's a really different experience as creating a Kotlin Multiplatform application from scratch. So in this case, we need to provide new model, and let's select Kotlin Multiplatform shared model template and provide its name and a package name. And also we need to select what will be the way to use and to work with iOS target as dependency. So our application, our common model will be converted into regular framework. Also, you could use CocoaPods, but I prefer to use regular framework in my case. In standard Gradle KTS, we need to provide all the dependencies. In different version of Kotlin Multiplatform, there is different approach how to provide and create iOS target. iOS target nowadays need to be specified for every target, for every architect target, and then it need to be commonized in iOS main target and used to work with common dependencies. So now let's add it to Android as a regular library, just like this. And to connect with iOS, we need to provide in special section in Xcode. It is run script, new script, and in this script we need to provide the path to our Gradle script and the name of the task to embed and compile our code into special regular framework and embed it in Xcode application. Also, we need to specify the path to search this SDK, and also need to provide linker flags to make it work correctly. Also, you could use cockapodes if you will turn your common model into cockapodes. Now let's move our business logic to common model. So at first, we need to deal with data models. Our data models by default use personalized and serializable annotations, and of course it is parcelable interface. So it is what we have when we work with Android. There is several specifics how to work with parcelize with Android and common code. In iOS target, parcelize have no sense, but to make it work correctly, we need to provide expect annotation to parcelize, and then with actual typelize, provide different links to this type. For example, in Android, it will be the link to type of parcelize, and of course, we need to provide the typelize parcelable to work it correctly. In iOS side, we need to provide interface for our parcelable and annotation to our parcelize. So yes, it is just a stop implementation in iOS side to make it work correctly and compile correctly. So now let's see. In Android, we use specific serialization library, and this serialization library have one specific approach. For example, we need to provide serialized name annotation before every field we use, and we shouldn't provide serializable annotation at the top of our data class. But in case of common code of Kotlin Common, we need to provide specific common version of serialization library, specific, and then we need to provide specific annotation over our data class, and the annotation for our fields will be not serialized name but serial name. So we need to make such changes and put all our code in common model. Now let's deal with network client. So at first we have retrofit solution. Of course, it should be your modern and most convenient solution. So it could be. So now we could use retrofit as the most widespread for network client in Android. And there is a simple retrofit where we have some requests to our API. And let's move it into Ctor. Before this, also let's mention that to deal correctly with providing our result mapping and to not to work with call or response in retrofit, we need to provide special call delegate that will map all our responses in special result to make it more understandable and to separate success and failure cases and to provide more sophisticated processing of it. In case of Ctor, we need also provide our special mapping to make it work with the result. So it is a special sealed class with two cases, success and failure, and then we're ready to work with it. So of course we could provide default result implementation. So it's also could be used in Kotlin Multiplatform. So you have different options. So let's provide in common code our Ctor version and all the libraries for serialization and logging, and also for network requests. And now we need to provide our expect actual implementation of our HTTP client. So there is our common network client, and we need to create a different engine for our targets. So as you can see on my slide, our network client use a special method to call our HTTP client and then map the result into our result. So it could be as result as silk class, or it could be also result as default result that is available in Kotlin Common by default. So now let's provide different HTTP client engines for Android and iOS. For Android, our HTTP client need to work with the OK HTTP config, and you need to set up just like this to provide JSON and the politics how to work with keys. And same operation need to be done with iOS. And we also provide our separated engine on the HTTP client. So it could be also not iOS create engine, but nowadays it's Darwin. And now we are ready to change the call of our default retrofit network client to our network client that use CTOR under its hood, and it's easy. So, and now we could move next, and let's work with concurrency. Of course, concurrency is still one of the most important pitfalls while working with Kotlin Multiplatform. So, as we know, iOS and Android are different. Kotlin JVM and Kotlin Native different, so Kotlin JVM concurrency and Kotlin Native concurrency different. And to deal with it, we need to provide expect and actual dispatchers, coroutine dispatchers, because we could use coroutines under our concurrency solution, and implement it differently for Kotlin Native and Kotlin JVM. Many people who worked with the Kotlin Multiplatform remember that it was a big deal while working with concurrency before new memory model management. So by default, we could provide dispatchers default and dispatchers main for Android. So there is no problem. And we remember that before Kotlin version 1.7.20, that was a big challenge to provide your own dispatcher and to make the workers with all the workers freezing and etc. Nowadays, there is no problem. Everything works okay. Everything works by default, so we have default dispatchers main working and connected with special thread within iOS SDK, and dispatchers default is bound with the global thread in iOS. So when we will call the context in our coroutine in our command code, and while calling this code from iOS side, and let's and trying to print the name of the context, we will have the name of the context in our console output, not only for Android, but also for iOS. So in this case, it will be dispatched coroutine with several identifier. And also, we remember that since Kotlin 1.4, all suspend methods bound into are mapped into completion handler methods. So there is a method with completion handler in Swift side that have two parameters, the result and the error. So the same we use in our common code, result and error. But since last year and since iOS 15, there is also another option that by default provide for us not only mapping into methods with the completion handler, but also async await method. And this async await method could be called in iOS side in special task wrapper. And also, for example, if we would like to put our code in our main thread, we could provide special main actor annotation. So this is done because of Swift interrupt. Of course, it's interrupt into Objective-C and then in Swift. But now it is working solution, so there is how this code is mapped with interrupt by default in shared model in iOS side. To make it more comfortable to work with such code, we could provide in iOS side special wrappers. For example, there is a special mechanism with checked continuation. It is resembled to our coroutines in Android side. And it will help us to map our code, for example, when we have the code with completion handler, to special async await solution, and for example, to map it in special result with content and error. So it is the same approach we use in Android side when we use suspended coroutine wrapper. So it is the wrapper in iOS side. Also, when we work with concurrency in Kotlin side, and of course we use it in both Android side and common model, we provide the result with the special flows. But to collect the data in iOS side, we need to provide the special wrapper for our collector. So we need to implement special class that will implement Kotlin X coroutine core flow collector and override emit method. And also we need to provide here special completion block to cut and collect all our data and then to put it in special variables. So it could be done just like this. I call this collector, or it could be also called observer, what you like. Also, you could provide your own name. So, and it could be set up and connect to our iOS code in our special view module. This is not common view module, but this is view module for our iOS code, just like this. So let's provide our collector. Yes, here I call this observer, and in this completion block I also collect all the values and put in special items, and then these items will update automatically my view and set up it in special places of my UI. So the same approach we use in Compose, for example, or when we listening to our flows. So to set up listening and collecting our flow, we need to provide while creating or getting the link to our view model from our common code, the link to our flow, and then call the collect with a reference to our collector and set up in completion handler in this case. Also, we could provide our special flow wrapper in common Kotlin side, and then it could be done. It could be provided just like a simple simple property that we could listen and got all the data in special completion block in our collect completion handler. And of course, we could wrap it in our async await in iOS side, also with check continuation, just like this. So we provide, we collect all the data, and in the collect and on completion error blocks, we collect the data and put it in special continuation resume and continuation resume for error. The same approach as for coroutines. So, and also you could use a ready-made solution from KMP native coroutines. So there is your choice what you would like to prefer, to use ready-made solution or to make solution by your side. And now let's set up our common AI and architecture. We need to connect our business layers. For example, we have our network service and API service. Of course, we could create it every time, but when we have different requests, different services that works with one network service, it could lead to different errors because we will recreate a network client once again, and of course there could be the loss of the responses from our requests. So there is what we have at first. We have separated network and network Android, and also have different mediators and different views, and just common logic that is not bound correctly. What we would like to have correctly connected network service with API service, and also common architecture that will deal with all this business logic and just provide all the data to our iOS and Android views. By default, we use dependency injection solution to provide all such logic. And in Android side, we use mostly MVVM mechanism of Jetpack Compose and Dagger Hilt as dependency injection with all this specific annotation. And of course, it's not solution for Kotlin Multiplatform common model. Yes, just for sample how we could provide the connection to Dagger Hilt, for example. And let's begin from making all this stuff common. At first, we need to create our common base view model. It will be just abstract class with the scope of common coroutine scope that will be managed in our view model. At first, I would like to mention that there is also ready-made dependency injection for Kotlin Multiplatform, and it's also work with both iOS and Android. And how to set up it in our case, I would like to show in a sample of Coin DI. Of course, Coin is also nice solution, but I prefer Coin because of the features, how it could be processed and how it could be set up in common code, and to make more convenient solution to be processed in common code and less in native side. So at first we need to set up our coin as special coin app declaration and to provide all the models we need to in our application. For example, we will provide a special model for our business logic and special model for our models. And for our business logic, we will use single. It's a singleton because we need only one sample of every service and network client. And even when we work with different recreated services, at one point there is only one start model point to create all the stuff. And our models will be connected with our views, so they need to be recreated every time we create our view. So we need to provide it with factory to create every time every new instance. And now we need to provide special kind component to provide all our services. We could declare all our services in this special coin component, and we could provide the instances of our services with the by inject lazy delegate, but it could be used only with the Kotlin common code or with get. So get is more convenient in our case because it could be called even from iOS native side. And moreover, with get, we also could provide special method that could retrieve for us the new or existed instance of several type by its Kotlin class. And this is why I like Coin. We could provide a special generic solution, put it in our common model, and then just put the type from iOS or Android native side and as a parameter, and voila, we have an instance of our service or our view model. Easy peasy. So to make it work with Kotlin native, we need to provide also our special extension in our Kotlin native site, and this extension will work with special Objective-C class instead of K class. Mostly we need to provide a first Objective-C class and then convert it in K class to make it correctly work. So, and there is our extensions. Why we need to use Objective-C class? Because it's a specific of interop. We use Objective-C class in Kotlin native, not K class. So, and we will get the getOriginal Kotlin class method to map existed Objective-C class into our K class. So this is a ready-made solution, and by default you could get from iOS side foundation, UI kit, and different types for common main. For example, we will retrieve the view model and the service that is already known for our Kotlin side, but all our native specific stuff that will be provided in our app is unknown for our Kotlin. Also, do not try to find and retrieve the instance by its name, because there is several specific between the names and difference between names in Kotlin native and Kotlin JVM side. So when we would like to get the class from the name of Objective-C class, we could use special NS class from string method. But because of mechanism interop, so you could know more about interop from this side. So it means that my slide is going on. So the specific was that in iOS native side, when you will open your shared model in Objective-C class inspector, you will notice that every type has special prefix, and this prefix is the name of your shared model. So you will have not the movie service, but shared movie service, not movie view model list, but shared movie view model list. And Kotlin a common module know nothing about this class by its name, but when you will provide the type as Objective-C class for movie view model list or movie service, it will be found and you will retrieve the instance, and then you could use this instance in your iOS site. So to know more about interop mechanism and what could be done also to make your code more convenient and to map your solutions from Kotlin to Kotlin native, you could find in special native Objective-C interop section in Kotlin Lang site. So, and this is our ready-made solution. You could try this by this link, by this QR code, and let's summarize. Thank you very much for your attention. What I could say about Kotlin Multiplatform, it's a really stable beta solution. Yes, it's stable solution, but better because of small difference between different versions. And it's mostly ready for production, mostly because also there is small differences between different versions. All the problems of previous versions are solved nowadays, and modern workarounds are not rocket science, so it's really easy to make your native Android application cross-platform. So, some sources, and thank you for listening. I'm ready for your questions.
Amazing talk, Anna. I really enjoyed listening to your talks. And I think one thing that I noticed is that I thought KMM was hard, but listening to you explain it made it so easy. And I realized it's some of the things that I use every day at work as an Android engineer. So pretty awesome. So I'm just going to share what people were saying just a little bit as a snail. As you can see that somebody showed you a thumbs up. Very nice. just to motivate you. So you did a pretty great job. As you can see, people loved. And then this was also pretty good. KMM Power.
So
That was
Flutter
very
Graph, yes,
idea.
yes, it's really the great challenge between Kotlin Multiplatform developers and Flutter developers.
Mm-hmm. So I think if you have any questions, please write them there. I will be asking them to Anna. But apart from them, Anna, I had a question. I'm actually surprised that I know I'm saying surprised because I've not used it, but you didn't mention health and also mentioned preferring coin over health. Do you want to explain why that is?
So Hilt is solution only for Android, but for Kotlin Multiplatform, we couldn't use native Android solution and native iOS solution. Uh, Unfortunately, nowadays both Dagger and Hilt is only for Kotlin JVM, and I know that for Dagger there is specific works to make it working with the Kotlin multi-platform. For example, they're changing cap to KSP, and I hope then all the jobs will be done. We will have Dagger that could be provided also with Kotlin multi-platform, so it will be more easy for Android developers to make their solution cross-platform. Nowadays there is two ready-made solution is Coin in Kotlin, also is Kotlin inject solution. But
Okay.
for me, more convenient and more sophisticated and more comfortable to work is Coin because of this mechanism of retrieving the instance for both iOS and Android target by generics. And unfortunately, last time when I worked with Kotlin, there were no such mechanism, and we need to provide some workarounds that could be really harder for new buys of Kotlin multiplatform technology. And Kotlin and Coin in this point is more easy.
Okay, makes sense. I mean, totally makes sense. We do have a question, so I'm going to just play it for you so that you can just see it. And the question is, anything have you explored for DB? I'm guessing the question is, have you explored anything for DB?
So database solution, I only know about SQLite Lite, but unfortunately I haven't worked with it. And I know that Room works with KSP nowadays, so I hope that maybe in several iterations we will have Room that could be used with Kotlin multi-platform.
Pretty cool. Now, we do have another question, and I'm just going to showcase it for you there. And that is, first of all, nice talk, which is very true. I second that, nice talk. Was there a reason you defined view models inside coin module as factory instead of view model?
Instead of view model. So I think that both approach could be used. So factory is more maybe it's more common solution for all factories when you need to create new instance every time. Of course, you could provide your view model. It's the same.
Perfect. We have another question, which is amazing. I love when questions come when I do presentation. And sometimes, just to be fair, I feel like the questions are always very interesting, and then I end up not knowing the answer. And then I'm like, I'll look into that. Maybe we can talk about that. But the other question is Compose multi-platform and KMM different, or they are both parts that are dependent on each other?
So it's independent solution. Compose multi-platform could be used for KMM, but KMM mostly was designed as just a model of your business logic to provide it as multi-platform experience between different like to share your logic just as a library. And this is why it is compiled in libraries that could be connected separately. So you just could turn it into library, for example, and turn it into Gradle dependency or into Swift SPM and use it separately. So in this case, KMM is is independent from Compose Multiplatform, but Compose Multiplatform could be used to provide multi-platform UI solution.
Amazing. Thank you. Oh, I think there's a question. Oh, yeah, okay, not a question. There's somebody commenting there. So thank you very much, Anna, for this.
Thank you, Madana, for hosting.